So, welcome back sa ating lecture video series on differential amplifiers. Okay, so let's recall kung ano yung natutunan natin from the previous episode. So, this differential amplifier has a resistive load po dahil yung nakakonect sa ating collectors ng differential pair ay resistor po. And its input is differential, of course. That's the characteristic po ng lahat ng differential amplifier. Its input should be differential. And in this case, our output is also differential. So, ibig sabihin, our measurement ng voltages is hindi po with respect to ground. So, lagi natin mini-measure yung voltage between two nodes. So, therefore, we can say that this circuit is fully differential. Dahil differential ang output, differential ang input. And na-derive nating voltage gain, which is VOD over VID, is similar po sa voltage gain ng common emitter circuit na fixed bias, which is equal to negative RO in parallel with RL over RE. And its common mode gain naman is almost zero or meron lang po tayong maliit na value. Okay sir, I have a question ulit. Sir, paano pag gusto kong gumawa ng two-stage amplifier? Tapos ang first stage ko is differential amplifier, second stage ko is normal na common emitter circuit lang. Magagawa ko ba yun, sir? So actually po, if our output is fully differential, hindi po kaya yon. Okay? Dahil ang input ng ating common emitter amplifier is single-ended. So actually, yung example mo na differential amplifier yung first stage and normal na common emitter amplifier yung second stage, normal po yan. So pag tinignan nyo po yung internal circuit ng isang op-amp, let's say LM741 op-amp, makikita nyo that ang kanyang first stage is a differential amplifier and the second stage is common emitter amplifier. Pero, paano natin gagawin yon? Differential amplifier na diniscuss nyo, sir, is differential output. Paano natin yan i-connect sa single-ended input na second stage? So, ibig sabihin, may kailangan tayong i-modify dito sa circuit na yan. Para ma-convert natin yung differential output into a single-ended output. So, paano natin gagawin yun? So, madali lang po yan. So, instead of measuring the output between VO1 and VO2, what if just measure the output in one of the nodes po with respect to ground? So let's say, ida-drop natin yung VO1. Ang matitira na lang is VO2. Tapos i-measure natin yung voltage na VO2 with respect to the ground. So pag ginawa ko yun, ganito po ang mangyayari. So our output is just the voltage at this node with respect to ground. So ngayon, meron na tayong single-ended output po. Sir, are you sure that this one is still operating as a differential amplifier? Sure ba kayo that the output voltage is the amplified version of the differential voltage between VI1 and VI2? Actually, yes po. Diba? Kapag drawing natin yung half circuit niyan, which is this one, so unang-una natin ma-observe yung VO1 dito, from the last episode, nawala. Dahil nga, ito lang yung kukunan natin ng output voltage. So, nangyari, VO2 is equal to VO na mismo. Okay? And yung VI1 and VI2, hindi po nagbago. Si VI1 is still positive VID over 2 and VI2 is still negative VID over 2. So, nakita natin that half circuit number 2, ang kanyang input is negative VID or meron tayong component ng differential input. Diba? Ibig sabihin, this circuit also amplifies the differential input natin. Dahil yung VI2 is equal to negative VID, which is the differential input, over 2. Diba? So, since the output voltage is only measured sa ating VO2 na matatagpuan sa half circuit number 2, yun lang po yung ating i-analyze. Okay? So, kung mapapansin natin, this half circuit is equivalent po sa common emitter circuit na fixed bias. So, wala po tayong emitter resistance dito. So, therefore, VO2 over VI2 is negative RO in parallel with RL over RE. And we know that VO2 is equal to VO. And VI2 is equal to negative VID over 2. So by plugging in this VO2 and VI2 dun sa na-derive nating voltage gain equation, ang lalabas ngayon na differential voltage gain VO over VID is RO in parallel with RL all over 2RE. So tatawagin natin siyang AVS. So this is the differential voltage gain for a single-ended output. So next naman is the common mode voltage gain AVC. So again, kokopyahin lang natin yung half circuits dun sa previous episode. Tapos ang i-consider lang natin is half circuit number 2. Dahil ang ating output is only measured sa VO2. Unlike do sa previous episode, ang kanyang output is measured between VO1 and VO2. So right now, ang kanyang output is measured from VO2 until ground. So analyzing the half circuit number 2, similar siya sa common emitter circuit. Pero meron tayong emitter resistance na 2R out. So gagamitin lang natin yung formula ng common emitter circuit na unbypassed yung emitter resistance, which is negative beta RL over beta RE plus 2 times beta plus 1 R out. And if beta is high enough, tatanggalin lang natin yung mga beta dyan. So therefore, kapag kinuhanan lang natin ng output yung isang node with respect to ground, nagiging single-ended siya. Kaya anong nangyari, our input is still differential. Ina-amplify niya pa rin yung differential input natin na VI1 minus VI2. And our output will be now single-ended. Dahil with respect to ground na ang ating measurement. And the differential gain is RO in parallel with RL over 2RE. Or if RO is high enough, siya ay RL over 2RE. And the common mode voltage gain is negative RL2. So yung RL sa half circuit number 2 over RE2 plus 2R out. Dahil ang kinonsider lang natin when deriving the common mode voltage gain is the half circuit number 2. Okay, so anong mapapansin natin dito? So first nating mapapansin, mula sa differential tapos ginawa nating single-ended, nagkaroon tayo ng 2 dito sa denominator. So ibig sabihin, the magnitude of the voltage gain or the differential gain was decreased. Nakalahati siya. Ano po yung napansin natin? Sa differential output natin for resistive load, our common mode gain is approximately equal to 0. So ngayon, hindi na siya approximately equal to 0. Lagi na siyang may value, di ba? So ibig sabihin, the magnitude of our AVC was increased. So therefore, the maximum value of CMRR or the ideal value of CMRR was reduced from infinity to this one. Dahil si CMRR is defined as the ratio of the differential voltage gain to the common mode voltage gain. If the differential voltage gain was reduced and the common mode voltage gain was increased, of course, the CMRR will be reduced. So, yun po yung main drawback nitong circuit na yan. So, nagawa nga natin siyang single-ended pero pumangit naman yung performance niya. Okay, sir, may question po ako. So, is there a way to convert the differential output into a single-ended one without degrading its performance or the CMRR? Actually, yes po. So, take note, sa modern circuits po, sa modern design ng circuits, hindi po ginagamitan ng resistor yan. Dahil kapag meron kang resistor niyan, limited lang yung ating voltage gain. Dahil ang ating voltage gain is RL over RE. Diba? Or 2RE. So, if you want to increase the voltage gain, you need to increase RL. Pero, hindi mo pwedeng basta-bastang i-increase lang si RL. Dahil pag in-increase mo yung RL, si VCE ngayon will decrease. So, ang nangyayari, pag in-increase natin si RL, pinupush natin yung VCE towards the saturation region. And ayaw po natin yun. Okay? So, kaya ang gagawin natin, instead of using a passive load like a resistor, gagamit po tayo ng active load. Gagamit tayo ng current source as a load po. And paano natin nire-represent ang current source? Siya ay isang transistor na nasa active region lang, di ba? So, we can represent current source as a transistor operating in active region po. So, we will replace this passive load with an active load po. Ano kayang pwede? So, pwede po natin gamitin is current mirror circuit. Okay? So, we replaced the resistors RL ng current mirror circuit. So, actually, mapapansin natin dito, first of all, yung ating differential voltage gain was increased. Kasi kanina merong over 2 dyan, di ba? Nung resistors ang ginagamit natin. Ngayon, nawala po yan. And another thing is the output impedance was increased. Okay? Obviously, RL is much smaller than the output resistance ng ating transistor. Okay? So, kanina, RL over RE yan. Ngayon, output impedance or output resistance of PNP over RE. So, overall, tumaas po ang ating differential voltage gain. Okay, so hindi ko na po papakita yung derivation nitong circuit na to dahil medyo mahaba po ang derivation nito. So, isusulat ko na lang po sa ating class notebook or sa OneNote yung derivation. Dahil we cannot use half circuit analysis dito. Kasi kapag hinati natin yan sa dalawa, makita natin that hindi identical yung nasa left or half circuit 1 do sa half circuit 2. Dahil sa half circuit 1, meron tayong PNP na diode connected or connected po yung base and collector. And sa half circuit 2 naman, meron tayo na PNP na hindi diode connected. Di ba? So, obviously, hindi sila symmetrical. This circuit is not symmetrical po. So, mano-mano pong ide-derive yung voltage gain. So, sir, paano naman po yung common mode voltage gain? Kasi yung performance ng ating differential amplifier is depende sa CMRR. And CMRR is dependent sa differential gain and the common mode voltage gain. So, what is the common mode gain po niyang amplifier na yan? So, the common mode gain of this amplifier was derived as this one po. So, medyo mahaba. Okay? Pero kung mapapansin nyo, if RE1 is equal to RE2, equal to RE3, equal to RE4, so makita natin itong RE3 and RE4 will cancel out. Diba? Magiging 1 na lang po yan, yung multiplier nito. Mapapansin natin dito that this one, yung beta over beta RE plus 2 times beta plus 1 R out, minaminus natin yung beta over beta RE plus 2 times beta plus 1 R out. So, if RE is the same, so magka-cancel po yan. So, ang matitira dito is 0 multiplied by ROP. So, therefore, AVC will become 0. Pero kung i-recall natin, kapag meron tayong current mirror circuit, so if we have a reference current na I1 over here, hindi po natin perfectly mami-mirror yan dito sa second branch na I2. Kasi kung i-recall natin, we have the current transfer ratio sa current mirror circuits. So kapag ganyan po yung configuration, ang kanyang CTR is I2 over I1 is equal to 1 over 1 plus 2 over beta. Okay, since hindi infinite ang ating beta, masasabi natin that I2 will never be equal to I1, di ba? So, ibig sabihin, IC1 is not equal to IC2. So, yung values nila very close lang, pero hindi sila equal na equal. So, kapag hindi equal yung IC1 and IC2, hindi rin equal yung IE1 and IE2. Kung i-recall natin ang definition ni RE, it is the thermal voltage, which is 25 millivolts or sometimes 26 millivolts, divided by the emitter current or the quiescent emitter current. If IC1 is not equal to IC2, masasabi natin that IE1 is not equal to IE2. So, ibig sabihin nun, RE1 is not equal to RE2. Therefore, AVC will never be 0. However, yung mga values na yan, RE1, RE2, saka RE3 and RE4, yung values nila almost magkaparehas lang. Okay? Siguro may deviation ng, let's say, 1 or 2%. Okay? So, ibig sabihin, yung ating common mode voltage gain, hindi nga siya 0, pero it is very close to 0 po. Okay? So, to summarize, our differential amplifier with active load na single-ended has differential input and it has a single-ended output. Its differential voltage gain is the output resistance of the PNP over RE of the NPN. And the common mode voltage gain will be this one po. And its CMRR, ang expected value niyan, since this one is almost 0, makita natin si CMRR is mataas. Okay? So, ayan na po ang ating differential amplifiers. Okay. So, para lang makompleto natin ang differential amplifier, paano natin i-represent tong current source na yan or current sink dahil siya ay humahatak ng current papuntang ground. So, again, every time na makakakita tayo ng current source sa ating circuit, papalitan na natin siya ng transistor or BJT operating in the active region. So, magiging ganyan po ang ating circuit. Typically, ito po yung makikita nating circuit. Pag tinignan nyo yung specs sheet ng LM741, let's say, or any general purpose amplifier, its first stage is similar po dito, yung itsura niya. May transistor ka po dyan as a current source. So, this one is now called the 5-transistor operational transconductance amplifier, or it is the 5T OTA. So, kung mapapansin nyo, ang operation niya is similar to the operational amplifier. Nagkaroon lang tayo ng transconductance dito. Okay? So, ito po yung pinaka-simpleng circuit ng isang OTA. So, it is just a differential amplifier with active load po. And its differential gain and common mode gain is the same po dun sa kanina, sa previous slide natin. So, dahil dyan, for the next topic natin, mapupunta na tayo sa operational amplifier itself. Paano ba tayo bubuo ng isang operational amplifier? So, anong pinagkaiba ng operational transconductance amplifier? Pero first of all, sir, Bakit siya tinawag na operational? Lahat naman ng circuit na ina-analyze natin, nag-ooperate ng tama, it's operational, di ba? Pero bakit siya lang yung operational na amplifier? So, sasagutin natin yan sa ating next topic, which is the part 2 of our module 4. So, that's it for our lecture video series. So, natapos natin ang kwento ng differential amplifier. So, I hope natutunan nyo kung paano mag-analyze ng differential amplifier. Kahit active load man yan, or passive load man yan, single supply man yan, or dual supply man yan. Differential output man yan, or single-ended output man yan. So, that's it. I will see you on the next one. Bye-bye!